And we're back to do another podcast for all my unloving and hateful disciples. Here we go. The last podcast we did was on ecology, and so we are continuing with ecology. This is going to be about predator-prey relationships. We will talk about competition. We'll talk about invasive species. And we will kind of look at a sample graph of what a predator-prey relationship looks like, and then if we added a competitor, what would happen to that graph. Okay? So you should be familiar with predator-prey, what that is, competition, what that kind of is. If you're not, we're going to familiarize you with that a little bit. Okay? So looking at the whiteboard. Okay. So, here we go. Now, I have a few words up here. Hopefully you can see those. If not, push full screen. That might help you. Okay, predator-prey. Okay, a predator-prey relationship. Okay, the example I have down here, and these are kind of backwards, all right? The wolf is the predator, the deer is the prey. So the predator eats the prey. Okay? Now, in some situations, you will have a very unique case where you have one predator that always kind of eats the same prey. Okay, like the lynx and the hare, or what is a bigger type cat and a rabbit. Okay, that is a very classic example of this. In this case, we'll use the wolf and the deer. What the heck? We are all familiar with wolves and deer and the fact that a wolf will eat a deer. Okay? So in this case, starting with predator-prey, we're going to come and look at this graph. Okay, so what I have down here, my independent variable is time, years. I have it in increments of 5 years. Over on the left, I have numbers of animals. This would be in the hundreds to maybe thousands sometimes with different animals. Okay. Now what I see is I have two lines. I have a brown line and I have a purple raspberry line. All right. The brown line is the deer. The wolf is the raspberry line. Okay. Now there's a dynamic to most predator-prey graphs that people don't quite notice when they first look. Okay, so I drew a dashed line to kind of show us this dynamic. So what we see is my line travels straight up through kind of the center of this peak for the deer. What I notice is there's a lag between where the peak of my predator is compared to the prey. So let's talk about why that is. All right. Well, since the wolf eats the deer, the wolf is dependent upon this food source. Okay? If the wolf gets enough deer to survive, then it can reproduce and we can get more wolves. All right? If it does not get enough deer or food, then it will not reproduce, and it also could itself starve to death and die. So that would take numbers of wolves out of the population. Okay, and also if it can't reproduce, the wolf doesn't reproduce, it doesn't add numbers to the population. So what we see is, basically if we see a rise in the deer, then after a short period of time, a couple of years with the wolf, we will see a rise in the wolf population. So as the deer go up, the wolf follows after a lag time and also goes up. That makes sense because if we have more deer for the wolf to eat, then the wolf will have more food and the wolf will be able to survive and reproduce, and the numbers of wolves should go up. On the flip side, what if the deer then start going down? Okay, well, if the deer start going down for whatever reason, then the wolf will follow. It doesn't have enough food. The wolf starves to death or it can't reproduce, so the wolf numbers go down. Okay? So there's a lag time between. Now, does the deer have to go down because the wolf is eating it? No. Okay, this could have been a very harsh winter right here in the years between 5 and 10. Maybe in the year 7, there was a very harsh winter, which left very little food. So all of the young deer died. All of the old deer or the sick deer died. They couldn't get enough food. They weren't strong enough to find the food, to dig down, find the food. And so they died. So maybe there was a harsh winter here and the number of deer started to go down. Well, the wolf will follow. Because it is dependent upon the deer, the wolf numbers will go down because there's not enough food now to sustain that number of wolves in the population. Okay, so this could be a natural event, like a drought, a harsh winter, very cold. Okay, a drought would not produce enough food to sustain as many deer, and so the deer populations would go down. Okay, so the predator-prey should make sense. All right, so this was a very short video or podcast on predator-prey relationships. So in this case, remember, the predator, the wolf, is eating the deer. Okay, and as the deer go, the wolves will kind of follow. The wolf will go up, followed by a spike in deer numbers. Okay, now we can take one more little aspect here, one little dynamic, okay, and we could say, okay, well, what kind of, in this situation, is my carrying capacity for my deer? So we've talked about carrying capacity also. Okay, well, rarely do you see me go up above 300 to 350 deer. Okay, but when I drop down below 200, I seem to always rebound. Okay, so we wouldn't want to see our carrying capacity is right here at the top, okay, of the peaks. We would want to say that our carrying capacity is probably closer to somewhere here in the middle of the peaks. Probably somewhere around 250 deer. Okay, this ecosystem can't really support more than that. When they go above that, they drop back down. But it can support more than 200 or 180 here, because when they drop down below there, they always seem to go up. Now, I'm always going to have fewer predators than prey. Remember our rule of numbers, okay, our pyramid of energy. Okay, so I'm going to have fewer predators than I have prey. So here I have my line for wolves is lower. All right, it probably could be a little lower, but I want you to be able to see how the two lines interact with each other. Okay, so the wolf carrying capacity is going to be, in this case, somewhere down around 100, the center of these two peaks, of the peaks and the valleys. Okay, so that's kind of our podcast on predator-prey, and we'll be right back with a podcast about competition and invasive species. Waldman out.